Hello, you're welcome to Remedial One platform for learning. Today I'll be doing a video on chemistry practicals. We have a diagram here, and I want us to go through the diagram and then answer the questions that follows the diagram. So we have a diagram here. Figure 1 is an illustration of a simple experiment carried out by a student in the laboratory, of course the chemistry laboratory. Study the figure carefully and answer the questions that follow. So this is the diagram here. Now we have this diagram here. This is we have part labeled II. We also have part labeled III. Then part labeled IV is here. And then we have part labeled I. So the first question is, name the parts labeled I, II, and IV. And then II. What will happen to the sample of wet calcium carbonate when it is strongly heated? So we have the calcium carbonate. This is the wet sample. So what happens when it is strongly heated? Then question number 3, or III. Write a balanced chemical equation for the reaction that takes place in BII. Then let's continue. Then IV. At the end of the experiment, what happens to the anhydrous copper sulfate? So this is anhydrous copper sulfate. What happens to it at the end of the experiment? Then B. What happens to the lime water? This is the lime water. So what will happen to this lime water at the end of the experiment? Then the last question is that name one other substance that can be used instead of the anhydrous copper sulfate. So let's look at the solution. So I is a red dot stand and a clamp. So we have a red dot stand and a clamp. So that's the part labeled I. Then let's look at II. This is the part labeled II in this diagram. And this part labeled represents a test tube. So II is a test tube. So the part labeled II is a test tube. Then the part labeled III, according to the diagram here, III is a cork. Cork. C-O-R-K. Cork. So that's the part labeled III. Cork. It is used to cover the test tube. So that's a cork. And IV is a delivery tube. It is a delivery tube. So that's the part labeled IV. Delivery tube. Now let's go to the second question. What happened, or what will happen to the sample of wet calcium carbonate when it is strongly heated? In fact, when this calcium carbonate here, this wet sample is strongly heated, two things will happen. The first one is that it will lose the water, which is causing it to become wet. So the first stage is that the water on the wet sample will be lost. So that's the first thing. It will lose water. Then when you continue to heat the sample after it has lost the water, then the calcium carbonate will then decompose, or it will break down to give us calcium oxide and carbon 4 oxide. So the first thing is that when you heat the wet sample, it will lose water in the first place. And then the second thing is that if you continue to heat, then the calcium carbonate will decompose to give us calcium oxide and carbon dioxide, or carbon 4 oxide. So that is exactly what will happen when you heat the wet sample calcium carbonate. Then III. Write a balanced chemical equation for the reaction that takes place in BI. So as I said, when you heat the sample calcium carbonate, if you continue to heat it, there is a calcium carbonate. So this is the formula for calcium carbonate, CaCO3, solid. So this is the solid form. And then when you heat it, it will decompose, or it will break down, and then it will form calcium oxide. This calcium oxide solid, and carbon dioxide, or carbon 4 oxide, which is a gas. So this gas will escape, but the calcium oxide will remain in the test tube. Then let's look at the next question. At the end of the experiment, what happens to the anhydrous copper sulfate? So this is the anhydrous copper sulfate. Let's go back to the diagram again. This is the anhydrous copper sulfate. So you see, when you heat the wet sample of calcium carbonate, I said that in the first place it will lose water. So water will escape in the form of water vapor. And then when this water vapor passes through the delivery tube and enters this test tube containing anhydrous copper sulfate, the anhydrous copper sulfate will change color. In fact, the anhydrous copper sulfate is white in color. That's the anhydrous one. It is white in color. But the moment water is added to it, it becomes hydrated. And the hydrated copper sulfate is blue in color. So it means that this anhydrous copper sulfate here will change color from white to blue when the wet sample of calcium carbonate is heated in the first place. Because in the first place, it will lose water. So water vapor will pass through the delivery tube and enters this test tube containing anhydrous copper sulfate. This anhydrous copper sulfate is whitish in color. But the moment it becomes hydrated, or the moment water is added to it, it changes color from white to blue. So that is what will happen to the anhydrous copper sulfate. It will change color from white. Then the next question is, what will happen to the lime water? Let's look at the lime water. This is lime water here. So when you continue to heat the calcium carbonate, according to the equation, it will decompose. And when it decomposes, it forms calcium oxide, which will remain in the test tube, and then carbon dioxide gas. So carbon dioxide gas will escape. And when it escapes, it will pass through the delivery tube here, IV, and then enters this test tube containing lime water. And lime water will turn milky whenever it comes into contact with carbon dioxide or carbon dioxide. So at the end of the day, because we are producing carbon dioxide, it will turn the lime water milky. So that is what will happen to the lime water at the end of the experiment. Now, let's look at the other question. Name one other substance that can be used instead of anhydrous copper sulfate. So we are looking at any other substance that can be used to test for water in the lab. Normally, we use anhydrous copper sulfate, which is whitish in color, but the moment it becomes hydrated, or the moment water is added, it turns blue. But apart from anhydrous copper sulfate, we can also use anhydrous cobalt 2 chloride, that is COCl2, the anhydrous one. That one too, it will change color. In fact, when it is anhydrous, the cobalt 2 chloride is blue in color. But the moment it becomes hydrated, or the moment it comes in contact with water, it becomes pink or red. That it will change color from blue to pink or red. So that is the name of the other substance that can be used instead of anhydrous copper sulfate. So we can use anhydrous cobalt 2 chloride. Thank you for watching this video, and share and also like it. Thank you.